Okay, now we are fine. Mujiti, what is a vector? If you covered it in Python, but of course you can see that this is just a list that contains data of the same type, or maybe items of the same type, right? And then there's something we are mentioning that it is a list that contains. So list is also a different kind of data structure that we are going to look at. But when you look at list, it's exactly the opposite of a vector. I even mentioned it somewhere here, opposite of vectors, and it can contain data of different types. But when you look at a vector contains data of the same type, right? Containing data of the same type. So let's say, for example, um, here you will look at countries. We have Kenya, Bangladesh, Haiti, Guatemala, Jamaica. These are just data of the same type, character, right? And okay, Ronnie is mentioning that it's a type of an array that is one-dimensional. Yes, that's true. And you'll even be checking. Stella, you typed something on. It's a set of variables. Yeah, a set of variables, or maybe just call it maybe a list. It's a kind of list, but the type of list that contains only one type or maybe the same type of items of the same type. I mean, um, another thing to mention also. So we look at this example where we can write how to write vectors. Just do that, and then we use the concat. This C in this case means concatenate. I mean, it's a concatenate sign. So C, and then now you write them inside there. So I've started with an example of countries. Maybe I can write an example of names, or I can say present. Present. I just want like a list of people that are present in this class, and I'll have, for example, number one. There is Joseph, and there is I'm seeing there is Mudoni, there is Kasola, and several others. Maybe let me, before I finish with others, I say that there is also somebody like Eric. Uh, Sorry, there's Eric, and because of two-third gender rule, I'll have Evita, Evita here. So this is our vector. So this vector contains people who are present in this class. Of course, listing all of everybody inside this class will really take time. But yeah, you can have a look at that. Joseph, Mudoni, Kasola, Eric, Evita, and so many others. And if you press Control Enter or just run it here, run the current line or selection. So current line is this one. Selection can be I've selected maybe a chunk of codes like this, and I need to run all of them, right? Yeah. Okay. So when you run it, you can see here present is there. Let me minimize this to. Yeah, you can see in my environment there's present, a data called present that has been generated. So you can click Control Enter, or you can even write here print all these things, and then I add and it prints Joseph, Mudoni, Kasola, Eric, Evita. So I'm passing everything that I wrote it and including it inside print function, right? Or you can even write just present here and control enter. It still brings you the Joseph, Mudhoni, Kasola, Eric, and Evita. That is just defining a vector. Are we together? Alvin. Oh, Alvin is okay. Anybody who is feeling lost or wants a clarification? Okay, we are fine. So that is that. And so the same thing that I've written here, it's just translated again here. We have countries, Kenya, Bangladesh, Guatemala. Then I can run all this, and then you can see countries Kenya, Bangladesh, Guatemala, and such like stuff, right? Okay. So another thing also, we can even create a numerical sequence. So this is a vector that contains numbers. It's the same thing as writing numbers, uh, and then C, then 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no difference between this and line number 179. It's the same thing. So when you use a full colon, then it creates a numerical sequence, right? It creates a numerical sequence for you. So if you can even run this 180 and 79, and you can see that you have 1, 2, 3, 4, 5 up to the same thing that we've done here. We can even create it like this without using the C and the brackets, right? We can avoid using that, then just use numbers 1 to 9, and then control enter. And then when you run these numbers again, control enter, you'll find it 1, 2, 3, 4 up to. Maybe for demonstration purposes, let's write 10 to 19 so that you see that it is working. 10, 11, 12, 13, 14, 15, 16, 17 up to 18, right? So the same way I wrote here, print, so that I don't have to write present here. Because if I write present here, it means that I'm going to be seeing like the Joseph, Mudhoni, Kasola, Eric, right? Instead of writing that, I can just be writing print, and then inside it I pass I pass the vector, which is present, and present contains all these names up to here, right? So that is the same thing that I've done here. Print in bracket now the vector, which is count, and it contains numbers 1, 2, 3, 4, 1, 8. If you press it, I mean control enter or run it, you'll see that you have 1, 2, 3, 4, 1, 8, which I think is understood. Stella, are we together? Yes, Ronnie. Ronnie is also okay. GLM.
Yes, I'm okay.
Okay. Let's proceed. So you can see that we were creating a sequence of numbers, right? A sequence of numbers here. We can also have maybe a numerical sequence for decimals. So for example, I'm just calling it sequence, right? I can call it something else. Maybe I can call it even evita. Yeah. And then here I'll just maybe have to change it to evita, right? So evita is a variable that contains numbers ranging from 10.6 up to 20.6. And then if you run this one, you'll see 10.6, and then the increment, the increment, or maybe the interval is 1. 10.6 to 11.6 to 12.6, 13.6 up to 20.6, right? And then there's a comment here that if a number is not part of a sequence, it will not be used. For example, here you can see we are jumping from 10.6 up to 20.6. It's increasing one by one by one by one by one, right? Up to 20.6, you'll get the answer. But now in a case where we are coming from 10.6 up to 20.6, the next number should be 21.6, but our numbers is ending by at 20.9. So 20.9 is not going to be used, right? We stop where the sequence is making sense. Let's try to run this. You'll see that 10.6, 11.6, 20.6. Our end was supposed to be 20.9, but it is not part of the sequence, right? That's why we are not using it. Yeah. Notice that the last value has not been used. I think you can notice that, right? That the last value has not been used, the 20.9. Yeah, but again, we can also even specify the difference. When you check here, we are coming from 10.6, we are going to 11.6, 12.6, which means that the interval is 1, right? But we may want to specify we may want to specify the difference so that it doesn't become 111, right? So there is where you can write this. So let's start with, we are coming from 8.3. If you run this one, you'll see that your sequence now is 8.3 up to 20.3. Now we want to specify that we are jumping by 0.5. So it comes from 8.3, goes to, when it comes from 8.3, which number are we going to have next? From 8.3, which number are we going to have? Who is going to be the sacrificial lamb? Alvin is saying something. GLM, we are coming from 8.3. Which number are we going to have? GLM, you're not speaking, or if you're speaking, it's on a muted mic. Kasola, from 8.3.
8.8.
Yeah, so we are going to jump from 8.3 to 8.8 because the jump is 0.5. So 8.8, we are going to 9.3, 9.3, we are going to uh, 9.8 again. So that's the sequence. So you try running that and run sequence again. You'll see 8.3, 9.3, 9.8, right? And we can even ask ourselves something here. We can try to see what is the length of sequence of this sec that because this we named our vector sec, right? So it can count for us all these things. Let's try to see and add here length 26. So 8.3, you count all these things up to 20.8, and again you realize that we were supposed to end at 20.9, but it has not been used because it is not part of our sequence. So length of the sequence, length of this sec that we named Evita sometime back, it is 26, right? So for us to create this thing that we have here, it is similar to saying that we are starting from 8.3, then we are going to 20.9, but we are jumping by 0.5, which is what we have in this case. But now when you want to specify it this way, you have to use the sequence function. So that you don't get confused, we can name this one to, let's name it somebody else again, ubat. And then there's sequence function. There's this sec function, right? And then now inside here, you specify that you are coming from equaling to 8.3. Then we are going to, okay, let's start even, we are starting from 0.001. We are going to 0.2. We are jumping by, sorry, so here is supposed to be 2, 0.2, and then we are jumping by is equaling to 0.01, all right, and we want to go up to 0.2. I think it's going to be a very long one, but let's just try and see, because but so if you run this and run ubat, you can see that we have all those numbers here, right? And then you can even try to get what is length of ubat 20, right? So that is it. So this can be used for uh, numerical numbers, right? You can create a sequence of numerical numbers. So you can see that maybe the sequence function has 3 parameters, that is from, to, and by. So by is now the sequence interval, right? Now can you do this? There is this exercise. Can you write a vector containing logical values and print it out? Whatever length you want. Write a vector containing logical values. And somebody is going to tell me what to write. That one you can do in 1 minute. Very fast. Are you done? Joseph, tell me what to write. Write a vector containing logical values and print it out. Tell me the steps. What am I supposed to write?
You write logical underscore vector,
Hmm.
then less than
Yeah, let me just do that quick fast. Uh-huh.
uh, dash.
Dash.
Is it a hyphen? I think it's an hyphen. Eh?
Yeah, I've written that.
Oh, okay. Then small c,
It's the concat.
concat into bracket,
Uh-huh.
true, comma, false, comma, true, comma, true, then false, close bracket,
Uh-huh.
print into bracket logical underscore vector, close bracket.
Yeah, so that is again even how you can just write a simple um, vector containing logical values. So logical values, we mentioned that it is either true or false, right? And again, you will realize that if you write true, small letter, if you write true small letter, it is not going to it's not going to run. Or I mean, like true, yeah, small letters is not a logical value in R, but T is a logical value. So T just means true, right? So sometimes you can write true or you can write F capital, right? So if you try running it, you'll see there, and you'll also try running it true, false. 1, 2, 3, 4, 5, 6, 7. You can see now it's true, false, but here we wrote TF, right? So that is something that you may want to also just remember. Another thing, length we had mentioned. You can even try to see the length of logical vector. You just type length. Uh, you just type length and then add. So whatever it is that you want to confirm, logical vector, and you see down here it is 7. 7. So true 1, false 2, true 3, true 4, false 5, true 6, false 7. And then you'll be able to see that. We can also sort uh, elements in a vector, either in ascending order or descending order, depending on what you want, right? So for example, we have here countries. So countries, for example, Kenya, Bangladesh, Haiti, Guatemala, Jamaica. You can even add something like maybe Rwanda, there and run it. And then we go to we wanted to sort it, right? So you can sort countries, the data that we have up there, and write sort. If you write sort, it is sorting in. Is this one ascending order? By default, it's sorting by ascending order. We are coming from A going to Z. So Bangladesh, Guatemala, Haiti, Jamaica, Kenya, Rwanda. Now, how about if you want to sort in descending order? I want somebody to tell me how we can do a sort. in descending order. Somebody to tell us how we can sort in descending order. Let me pick a sacrificial lamb. Nathan, or it's Nathan.
I have just joined. I'm trying to board the ship.
Okay. Yeah. We are not far away from the shore, so you can swim and find us on the way. Let's see. Mwema, how can we sort in descending order? No idea. Anybody who has any rough idea on sorting in descending order? Kinoti? Kinoti, you're trying to speak and your microphone is. It's like you're trying to speak and the voice isn't coming out. Okay. Any last attempt? Sangoro? Yeah, Ronnie is saying something. Is Sangoro there? Okay. Yeah. So what what you can do is to add another thing here and say maybe so the suppose maybe this is the equation that we are writing now. So you just add in decreasing. So you can see sort dot default logical. Should the sort be increasing or decreasing? Right? That is one question that you may want to answer. And then so you can just write T to me that it is equaling to true. If you run it, you'll see now Rwanda is starting. And then we are going to Kenya, Jamaica, Haiti, Guatemala, Bangladesh. Right? If you say that decreasing equaling to false, then it will just get us back to what we had. Right? And try running it, you'll see Bangladesh. You can see now this line of code here, not right line of code, but this output is the same as this output that we had here. I hope that is something that is clear. So if I write decreasing is false, it's just the same way as just leaving it this way. All right. Yeah. So this one is mostly it's negative or negating something. Yeah, so it's false, just a negative, uh, more of a negative, I mean. So how can you sort in descending order? That one we have answered it here. So you can just copy this and say control that and control V and say decreasing is equaling to true. Now we want to do some things called manipulation, vector manipulation, right? So vector manipulation. Manipulation, I mean, you can do addition, you can do subtraction. So you can see we have vector number 1 here and vector number 2, like this one, 3, 8, 4, 5, 0, 11. Then we have another one, 4, 11, 0, 8, 1, 2. Of course, these ones are just the same in terms of the length, right? So you can run the two. These are just simple stuff, right? If you run the two and maybe print V1, if I print V1, I can see them here. One dimensional, you can even see one. So we have just V1 there, and then we have V2. Right? You can see values of V2 411 0812, right? We may want to do now maybe addition. So we want to add V1 and V2. Yeah. So we can create another vector here, or like we can store the result of that addition into this vector that we are calling add result, right? Or we can just even call it vector 3, right? And then we can say print vector 3 and run this one. So if we add it, you'll see 3 plus 4 is 7, 8 plus 11 is 19, right? And you can also see that 4 plus 0 is 4, and 5, 8, 13, 0, 1, 11, 2, 13, right? That is vector addition. Similarly, we can subtract, right? And call it maybe V4 and say V1 minus V2. And then we want it to print V4, right? We can tell it to print V4, or we can just write here V4, and then everything will have the answer. And then you can see V1, 3 minus 4 is negative 1, 8 minus 11, negative 3, 4 minus 0 is 4, 5 minus 8, negative 3, 0 minus 1, negative 1, and 11 minus 2 is 9. That is vector subtraction. We can also do vector multiplication and multiply V1 and V2 and maybe call it V5. And then we tell it to print V5. We are multiplying V1. Multiplication sign is that asterisk. And then we control enter, and we have 4 times 3 times 4 is 12, 8 times 11 88, 4 times 0, of course it's not 40, it's 4 is 0, sorry. 5 times 8 it's 40, and then 0 times 1 is 0, not 0, 1, and 11 times 2 is 22. And we can even do vector division. We had also talked about division signs, division sign in yesterday. So you can even call it V5 and say print for us our V5. And we'll have the answer here as control enter, and then we will see. There's here that you are being told one of the answers is infinity, or maybe infinite, right? But yeah, that should be 0. We have division of 4 divided by 0. Right? Yeah, 4 divided by 0. Any number, 4 divided by 0, any number divided by 0, of course, it's infinity. Basic maths 101. And then we have, of course, 0 divided by 1, and then we have 11 divided by 2. We have 5.5, and such like that. Yeah, up to there. Any question? Anjeru,
Yes,
how are you?
I'm good.
Yeah, are you with us or you're with them? Are you okay up to that point?
We are together.
Okay. Anybody having a question? Hubert, are you following? Hubert. You can turn on your microphone. I will or type in the comment section that you're okay. Before we move to another concept, and this concept is called accessing maybe elements in a vector, right? Yeah, you can see here now we are done with those divisions. Now you can access maybe a specific vector by using index numbers. So index numbers is maybe the position of that vector, or maybe that vector element that you want to access, right? But you put it inside these square brackets. The square brackets are found on the third row of your keyboard towards the end, right end next to the stroke. So you'll see it there, and we want to maybe write this elements or maybe this vector. We have a vector here called maybe let's call it days, right? And we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? Or we can just have this as that. So you can run this and you can see days. Days here, it's the character containing this day is Sunday, Monday, Tuesday, up to that side. You can see something like present that we wrote was a character, the V1s up to V5, numbers, data type, right? Yeah. So suppose maybe we want um, to access maybe elements of this vector called the days. So here we'll just change it to days, and then I want to store this thing in another vector called maybe subset. So this whole thing that we are doing is called subsetting. There's subsetting. So if you're going to look at more reference on that, just go and write, or maybe just go and look for what we call subsetting in vectors or subsetting vectors. How to subset a vector, right? So here I'll just say print this subset, right? So I want to access maybe elements 2, 3, and 6. So number 2, Monday. Well, first let us run this subset and print it. Print subset. You'll see that we've gotten Monday, which is 2. Position number 2 is occupied by Monday. Position number 3, Tuesday, and number 6 is occupied by Friday, right? If I wanted to access just one element, I needed not to use this C, the concat, right? If I need to just access element moja, maybe I want to access the element occupying number 7, right? I'll just do that and then print my subset. And you see that element in the position number 7 is Saturday, right? Is that understood? Type yes that you are okay. And Kasola, that is okay. Next, waiting for the yeses and nos. Stella is saying Rudia. Kindly repeat. Are there yeses? I'm waiting to see if there is a yes. I've only seen one yes from Kasola. Ronnie. Joseph. Joseph, are you okay?
No.
Okay. Let's start with the gist and go to. Let me see if there's somebody called. So Evita is not there. Okay. So suppose I want to access maybe just one element in. Maybe I want to access the element that is occupying position number 4. I'll just use those square brackets and write there days 4, right? And maybe on if you run this, you'll see that it is Wednesday, right? It is Wednesday that is occupying position number 4. How about the one occupying position number? So you have to ensure that the name is exactly the same as the vector that you're trying to subset, right? So use the square brackets again, and maybe we want position number 1. Control enter. We'll have position number 1 ni Sunday, right? And maybe I want position number 1 and position number 4, right? I'll just write days, but I can't subset it this way, like niandike 1 and then 4. If you try to run it this way, you'll see that incorrect number of dimensions, right? But that means now I'll be introducing the concat inside. Then when you now run it, you'll see that position number 1 is Sunday, position number 4 is Wednesday. I can write maybe I want numerous of them. So see, I want number 1 and I want number 3 and I want number 5 and I want number 7, right? And control enter. I'll see Sunday, Tuesday, Thursday, and Saturday, right? Up to there, Alvin and Stella, are you okay? Stella is okay. Alvin, okay. Now, suppose I don't. Um, there's that time when you are talking about Power BI and we were looking at removing columns, and you may be having like maybe even 50 columns, and you just want to remain with you want to remove even the last one, or just remove the last 5 so that we remain with 45, right? So that instead of marking so many columns and remove, you'll just maybe click the ones that you want to remain and maybe say remove other columns. In this case also, maybe there's an instance where I want to show 1, 3, 4, maybe number 1, 2, 3, 4, 5, 6, 7, right? But I don't want to show the last one. Let me just write this and then you see what I'm talking about. C, and then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So I want to remain with days occupying number 1, number 2, number 3, number 4, number 5, number 6. Number 7, I don't want to be appearing. So I can type all that and then click Control Enter. You'll see that I have Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday, right? But that can be tiresome, right? Instead of writing this, I can decide to write days, right? I can decide to write days and then say minus 7. If minus 7 meaning I don't want to see the position number 7. I don't want to see the vector occupying number 7, right? So it's what I have written in line number 246, it is this 246, it is the same as what I have in 245. But this one in number 246, it is shorter, right? I don't have to take time typing so many blah blahs, right? I hope that is understood. Nathan,
Yeah, I have understood.
anybody who has who wants a repeat on that? Mama Mwendwa, Anybody wants that to be repeated? Mama Mwendwa, the power has gone. Where are you? Let it not go where we are here. Yeah. So let's see somebody who is Alvin, are you okay? Yeah, Alvin is okay. Yeah, so Mama, what I was saying, Mama, is that I may want to see day number 1, 2, 3, 4, 5, 6, but I don't want to see number 7, right? Or let me say I don't want to see number 1, or let me use 1 in the middle. I don't want to see day number 3 and 4. So I want to see the others up to number 7. So I don't want to see day number 3 and 4. So I've just left number 1, 2, 5, 6, and 7. So I'll run this one and see that I have Sunday, Monday, right? Which one are we not having? So Sunday, Monday, and then we don't have Tuesday and Wednesday because they are occupying number 3 and 4. Then I have Thursday, Friday, and Saturday, right? So that is this equation. So not this line, 1, 2, and then 3 and 4 we are omitting. This same thing here, it can be written as let me see. So how can we write it when we have the, okay, let's see if it's working. Minus C 3 and 4. Yeah. So you see it's again running. So when you put a negative, it means that we are omitting a certain set of elements, vector elements occupying the indices that we've mentioned. So you mentioned maybe index number 3 and index number 4. We don't want to see them. So you use the negative. You use this negative to minus, I mean, to tell it that can you subtract 3 and 4 out of the output? We don't want to see them. Similar, I can even maybe, I don't want to see output number 3, 4, 3, and maybe 5 and 7. I don't want to see those ones. And then so I only have Sunday. Sunday is occupying position number 1, Monday position number 2, but position number 3, which is Tuesday, has been omitted. Position number 4, which is Wednesday, is there, right? Number 5, which is Thursday, has been omitted. Number 5, which is Friday, has been included, right? Sorry, Friday is number 6. Number 6, which is Friday, has been included, right? And number 7, which is Saturday, has been omitted. That's it. Mama, you're okay? Cool. Let's go to another thing. Yeah, I think all these things that you're mentioning here. So yes, Alvin, your hand is up.
So I have a question.
Yes.
Whenever you can hear me.
Yes,
Sorry.
we can get you. Alvin? I am able to hear you, so I don't know why there is an issue with your mic. Okay. You can even type in the so Alvin is asking that does R start from 0 like Python? Here maybe as you've been shown here, you'll see that maybe um, when we type 1, then we start with the Sunday. So Sunday is in position 1. Can you try maybe writing position number 0, and then you see that day 0, character 0, right? You'll see here there is character 0, right? So maybe if you can check, it's starting from number 1 and going up to the highest numbers that you have. So it's starting from 1 going up to wherever it is that the values are ending at. So number 1 is Sunday, number 2 is Monday, and such like stuff. Alvin. Okay, great. Yeah. So I think these are things that you've talked about. These ones try to access the third country, maybe countries occupying position number 2 and 5. Country, I don't want to see country number 4. You can even run all of them and just see. So I don't want to see country number 4. So it has been omitted inside here, right? It should be something like, it should be Guatemala, right? After Haiti, we had Guatemala here. Yeah. So country number 2 and 5, Bangladesh. Yeah, you can see here, country number 4, it's Guatemala here. So it has been omitted in the last one, right? Okay. Uh, so we can change this one to days and maybe say, so accessing vector elements using logical indexing. You can also access vector elements using logical indexing. If it is true that there is a value occupying, is it true like we have a value at this point, right? Is it false that we are not? Is it true that we are not having a value? Of course, if you mention that it is false, then it means that it is we are not having any value there. False, 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 true, right? So if you check Sunday, it's true that we have Sunday occupying maybe position number 1, right? And we also have true for Friday, that is um, occupying the sixth place. But it is more of like, do we have a value at this position? Is it true that we have a value? Yes, it is true that we have a value, and that value is Friday. Is it true that we have a value here, right? Then it's true that we have a value that is Sunday, and then you can just try to play around with that. This one we've mentioned that, and we can also talk about even adding and changing an item, right? So if you look at our countries, let's just type it again so that we see what countries countries and control enter, you'll see we have Kenya, we have Bangladesh, Haiti, we also have Guatemala, and we have Jamaica, or it's Jamaica, for those who are fans of those kinds of music. And then we have Rwanda here. You can also visit Rwanda. Haiti for those of us who are going to help US fight the war. And Kenya, of course, you know the characters of Kenya, right? Thailand in Bangladesh, or Bangkok in Thailand. Bangladesh, you can also check even what is the capital city. But I mean, those are just hogwash. You may want to add or change an item to your vector, right? You may want to add, maybe here we have Kenya. We have six countries, and maybe I want to change. I don't want to see Rwanda here. I want to see Yoweri. That is Uganda, right? So I can mention that countries and then add that the brackets and say that the country occupying index number 6, I want to pass Uganda into that position, right? Uganda is the one supposed to be occupying that position, or maybe should be the data that we have. So if you run it, you can see that we are no longer having Rwanda in position 6, but we are having Uganda, right? Was that too fast? Kinoti? Who else? Anne, you okay? GLM, are we together? Okay. GLM writer is okay. Victor? Victor and Anne. Okay. Kasola. Uh-huh. So that is that. So here what you have done is to change an item, right? Same way you can even change Kenya to Mauritius. Can you try changing that? Or you can even try adding 3 countries at a go. Somebody to do for us this one. And Pashamai, give us the code to add this, to add these 3 countries. We had to add 3 countries. For example, maybe which country do you want us to add? Type in the comment section the countries you want to be added. Type your list of 3, not Pashamai, but everyone. Uh, and after typing, add them. India, UK, USA. Yeah, add that. Now it will be occupying position number. So add them in your list, and somebody to tell me the answer. Somebody to tell me the answer. I want to write it. Last time it was Joseph. Right now it's Pashamai. Pashamai, give us the line of code that you're supposed to write. I mean, these are basics that we are learning. These are just not really job breakers.
Okay, let me try.
Yeah, try.
So countries,
Singapore, South Africa, Australia. Countries.
then you put square bracket,
Uh,
you put a C, you concatenate,
Mm.
then you open the bracket, then you can write 2,
You can
4,
write
5.
two. Sorry.
2,
Uh,
you can write 2, 4, 5. Then you close the bracket. Then after that you put less than, then you put less than, then you put those countries.
How am I putting the countries?
Okay, you put you put an is it an even apostrophe? Then you write the countries.
It's called quotation.
Okay, quotation.
So which countries do you want me to write?
Rwanda.
No, let's get away from Rwanda. We already had Rwanda sometimes in the past.
Okay. Ethiopia.
Why are you going to Ethiopia?
Nigeria.
So I put them under one
Yeah.
quotation.
I know.
Uh-huh.
Then comma.
Uh-huh.
Nigeria.
Uh-huh.
Then comma. Then South Africa.
You can even get out of Africa.
Yeah.
You don't know any country outside Africa.
I know. Okay, you can put USA, America.
Okay. USA. So this way.
Yeah, that is how I think. I don't know.
So if I try running it, it's telling me unexpected symbols. Who can edit this? And again, we were adding, we were not changing. We are done with the changing because here we changed a country that was occupying position 6. So we are adding more values into our countries. But thanks for that. You've tried. Who is doing modification to this one? A lady. Jeru. Jeru. Mudoni, you can save Jeru. Yeah, Njero was saying you can help us edit this line of code here because it's not working. You can see there is a red unexpected token, and you tried running it, and then we are told that unexpected token, right? Somebody to chip in, Mudoni, or Mudoni has left. Okay. I mean, you should not be running away from. So we were at number 6. Kenya, 1, 2, 3, 4, 5, 6. So we want to add maybe position number 7. We had to add position 8 and also 9. But again, you can't leave things hanging this way, right? You can't leave things hanging, right? So 7, 8, 9, and then that is it. So of course, Pashamai, what you did here was just okay, but we wanted to add more data, not to change. So what you needed to do is to add this concatenate so that things are not hanging. If you leave them that way, you can't really add them until you include this concat, right? So if you run countries again, you'll see that now we have Ethiopia, Nigeria, and US included in the conversation. So you can change Kenya to Mauritius the same way we did here. You just have to identify what is the position of Kenya, which is position 1, and write here 1, and then write here Mauritius. And then, so here we are not using concat because it is just one element, right? But if there are more than one, similar to even this place, if it is more than one, then we are using the concat, right? And I think that should be evident now. And then now you see number 1 is Mauritius. So those who want to go to Maldives, you can also add that. Right. Another thing is there's this part where you can repeat vectors using the rep function. That is the repeat function. Right. So you can also repeat a vector. So for example, let's try to write. Let's start with each, and then countries repeat. So of course, this thing can even be another name, but I'm just using it to mean that we are repeating countries, right? So we want to repeat countries, and then use the rep function. There is a function called rep for you to repeat something in R, and then countries. How many times do you want to repeat? We want to repeat each value 2 times. Yeah. If you press or if you run, I mean, you'll see Mauritius has been repeated. Mauritius has been repeated. So we repeat them first before going to the next value to repeat. Bangladesh and Bangladesh repeated again. Haiti has been repeated. So we are repeating each 2 times, right? There's a different scenario where you use times. So who has seen the difference? When you can you run that? Run it and tell me what difference you people are getting. We start with the Ngetich. If you use times and each, what is the difference you are noticing? Is it Ngetich or Kimutai?
Both of them.
Okay. Tell us the difference that you've seen. Nathan?
I'm trying to run.
Yes. Joseph, which difference have you seen?
Working on it.
Who has seen any difference? Uh-huh. Casola Collins is saying that for times, Casola is saying that for times it is like repeating. It is like repeating the vector. For each, you are repeating the contents of the vector. Something of that sort. That is what Casola Collins is mentioning. Yes. So that is the difference that you notice when you try that. And here you can see we are doing Mauritius, Bangladesh, Haiti, Guatemala, Jamaica, up to USA, and then we start it again. It's more or less like we are repeating. In this case, we are repeating the vector, right? But in this one, we were repeating more of like the contents of the vector. So Mauritius and Mauritius going to Bangladesh, Bangladesh, Haiti. In this case, it's Mauritius up to USA. Then we start it all over again. If we want it to repeat maybe 3 times, the vector to repeat 3 times, we'll just add. If we want it to repeat 10 times or even 100 times, you'll even try that and see that you have a very long list of, it has repeated 100 times. So we have all this is a vector. So it has gone Mauritius up to USA 1. Mauritius up to USA again 2. And that way up to, how many values were we having? Let's see, length. It should be 9, eh? Yeah, so length repeat. Length repeat right now we are having 900 values. So 9 times 100 to 900 values. Okay. One last thing about repeat. We can repeat every value independently. You can repeat every value independently, right? And you'll see it in this example. So maybe let's create a vector called animals, right? So we can have a vector called animals, and then let's do it this way. So we can have a vector called animals and store, or let's use a different thing, call it courses or maybe departments. Uh, or even you can call something like maybe KPIs, key performance indicators, right? What are some of the KPIs that you know that a business can be focusing on? Give me an example of a KPI, key performance indicators. I'm waiting for answers. Yes?
Merchants onboarded per month.
Merchants onboarded.
Yeah.
Uh-huh. Yeah. So again, these are things that can be different from company to company, right? Maybe for a company, what they really wanted is we wanted to maybe target new customers, maybe 100. That is our key target. Like, so if we surpass that or maybe we get close to that, then we know that maybe we have performed according to how we really wanted to do it, right? So again, these are things that can be, every company has its own vision, targets, and such like stuff. Maybe our sales is to hit 1 million, right? That is my one of the things that we are targeting, right? They are just targets that a company is putting up for them, right? So that they realize their business objectives and things like that. So this is something that can be uh, that can be uh, different in terms of company to company. Yeah. So maybe one of the key performance indicators for maybe target new customers. Of course, they can be really long, but we might not need to write all of them. So that can be we can just get back to something that can be a little bit short and maybe mention like even fruits or workouts, type of workouts that somebody can be doing. What are some of the workouts that people do? You can be Stella. Do you have any workout that, or Stella left the call? Okay. Any workout, Ronnie? So you can have maybe squats, right? We can have maybe another thing like you can have something again like what? Dumbbells. Is dumbbells a type of bench press? You can have even shoulder press, right? Any other thing in workout, Victor? Do you know any other type of workout that you can be doing?
Lunges.
Lunges. Victor is thumbs down. Yeah, lunges. I believe maybe that should be the spelling. So these are just things that you can be you can be doing, and maybe push-ups and such like stuff. Anyway, away from that. So we have squats, bench press, and shoulder press, lunges, and things like that. So let's define it and say this is our vector called workouts. So we want to repeat workouts, but we want to repeat the values independently, right? So I can have workouts, and then have it that way, and then say, okay, or workouts repeat. Workouts repeat, and say use the repeat. So this is the repeat function or replicate function. You can see that there's somebody relating. So we have workouts repeat, and then we have what are we trying to repeat? We are repeating workouts. Let's see if it's going to work. There's a way I'm trying to think of it. And let's say times is equaling to C. And then we had 1, 2, 3, 4. Four values times maybe 5. I want this one to repeat 2 times. I want the other one to repeat 3 times, and the other one to repeat maybe 7 times. So this is 5, 2, 3, 7. And then control enter. Then print workouts repeat. Workouts repeat. And then you can see it has repeated, right? The why I wrote them 5, 2, 3, 7 4 times is because we had 4 entries here. Number 1, bench press 2, shoulder press 3, and lunges 4. How about if you write them this way? You omit 1. If you omit 1, then it is telling you that invalid times argument because you've not taken care of all the entries that we had. Yeah. So lunges has been repeated 7 times. Lunges, and then 4 there, 5, 6, 7. So you can play around with that. That brings an end to vectors and opens the way for matrix. Up to that point, any question? We've spent so much time on vectors, and there are numerous things that we've talked about there. We'll just repeat them in matrices. For example, these questions. What is the element in the first row, third column? You'll just do one and then you'll see. Any question? Joseph, are we together?
Yes. Yes.
Okay. Anybody having an issue? Okay. Silence means we are as fine as old wine. Let's go to matrices. And I'll again pose a question that what is a matrix? Ronnie. Yes? Okay. If you want to know what a matrix is, you can even type. So when you want to access help using R, you can just put a question mark and then type matrix there and then run it. And you see on this section where the help view is, you can see that we have some help for you. So you can just even enlarge it using that. So matrix creates a matrix from given set of values. If you want to write it as matrix, then you are attempting to turn the argument that you are passing there into a matrix. Its matrix is more of just trying to confirm if whatever you have is a matrix. And I think these are the things that we talked about yesterday, as factor, as list, as vector, as character, and such like stuff, right? Yeah. So the arguments for matrix, you'll even go through that detail. You'll see so many things, and even run examples, and you'll see even this is a matrix MDAT, right? Matrix C 1, 2, 3, 11, 12, 13. Number of row, we want to have 2 rows. Number of columns, we want to have 3. By row is equaling to true. And we want to have dimension names to be this. Anyway, we'll talk about that. So this is more or less the structure of of a matrix, right? So when trying to write a matrix, data, of course, whatever it is that you're going to be passing there. Number of rows, maybe 1. Number of column, I have 1 column. By row, equaling to false. You will see what by row means. By row means that the values that we've passed, we are arranging them. So if it is 1, 2, 3, so we go that way, 1, 2, 3, and then the next row is taking maybe 3, 4, 5, 6. If I say by row equaling to true, that explanation that I've given. If I say by row is equaling to false, then I'm going to arrange 1, 2, 3 as the first column instead of 1, 2, 3 being the first row. 1, 2, 3, column number 1, 3, 4, 5, 4, 5, 6, column number 2, and that way. You may not get it when it's said. You may get it when you run. So this one, so maybe we are creating a matrix called mat, right? And then now you use the matrix in bracket concat. So concat, because we are having different values, so many values here, right? 1, 2, 3, 4, 5, 6, 7, 8 up to 9, right? So matrix is equaling to that. Then we are saying that the number of row is equaling to 3. Then the number of column is equaling to 3 also, right? Let us first run it. And then if you run mat, you'll see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So by default, R has by row as equaling to false. By default, it is this way. So that is if you don't include that by row. So R will be arranging it in terms of column. By row equaling to false. So 1, 2, 3, first column. 4, 5, 6, second. 7, 8, 9, the same, right? How about if you have it as by row is equaling to true? And again, in some cases, you don't have to write n row equaling to 3, n col is equaling to 3 also, right? If you just write one of them, even you can even write n col is equaling to 3, then don't write n row is equaling to 3. It's still okay, right? Yeah, so you can choose just one, n row is equaling to 3, and then we are arranging by row, and then we are saying by row is equaling to true, right? If you run this, so you'll see. Now you can notice the difference. We have 3, 8, 17. If we could have said by row equaling to false, 3, 8, 17 would have occupied column number 1, but now it is occupying column it is occupying row number 1, I mean 3, 8, 17. There's a question you are being asked whether you notice the difference. Is anybody having a question in terms of creating a matrix? Alvin? Victor? Victor is okay. Mwendwa? No, Collins. Yeah. Kinoti is mentioning something that you repeat on by row. By default, okay, you are supposed to be declaring here. It's either by row is equaling to true or by row is equaling to false. That is the first argument that you have to understand. If you say by row is equaling to false, then your values are going to be arranged column wise. So it will count. If the number of columns we are having is the number of rows we are having is 3, right? Then it will count the first 3 values, and it will have them as the first column, right? Because we said by row equaling to false. So we are arranging them by column, right? So it will count 1, 2, 3, column number 1, 4, 5, 6, place it in column number 2, 7, 8, 9, column number 3. That is, I hope it's understood. Column number 3. If you say by row equaling to true, then 1, 2, 3, row number 1. 4, 5, 6, row number 2. 7, 8, 9, row number 3. And yeah, so you can see that. And then we did this example, and maybe if you say by row is equaling to false, it is just the same as just omitting it, because by default it is arranged column wise, right? That is if you don't declare by row is equaling to true. If you don't have to write by row equaling to false, I mean, right? Yeah. So if you know by row is equaling to false, just leave it that way. That means that it is going to be arranged, though we don't have something like by call. We only have by row, right? So that way. So if you run this, you'll see that if I run this one, the first one, and then run this mat, I'll have them arranged 1, 2, 3 as occupy the first column, 4, 5, 6 second column. But if I have here by row equaling to true, you'll see the difference now. And maybe you'll see now the difference. By row equaling to true, you see now I have 1, 2, 3, row number 1, 4, 5, 6, row number 2, 7, 8, 9, row number 3. By row equaling to false, 1, 2, 3, call 1, 4, 5, 6, call 2, 7, 8, 9, call 3. That I hope is understood. And you may want to add names so that you have names of, for example, you can see here column number 1, the heading is just like 1, right? One, of course, this one, of course, it's specifying that it is the first column. This 2 here is specifying that it is the second column. 3 here, third column, right? If we want to have the to have the names, or maybe to add the names of these columns and the rows, we can first declare something that row names. We can create two variables, one for row names, two for call names. Call names means the column names. So I'll maybe say concat row 1, row 2, row 3, and then this other one call 1, call 2, call 3, right? And then just run them. So R understands that there are these kinds of there are these two types of there are these two variables. We want to use them for our column names and row names. So we create now that matrix. You can just mention maybe a different kind of matrix, like maybe okay, mat1. This is not mat1. So matrix ready to contains, you can even change these values to maybe 11, 22, 30, 47, 25, 16, 71, right? 8.1, 9.9, right? And then now, so this is the first thing that we could be doing. We could even create the matrix first. I'll show you. So mat1, and then it contains that number of rows that we want to have is 3. And again, chunga, here we have 11 because there are 9 values. If you have 10 values and then say by row equaling to 3, this thing is not going to run because we are going to have one row having less values. It really has to be a square matrix. If it is 3 by 3, not really a square, but something that makes sense. 2 by 4 will really make sense, right? But if you have the number of rows as 3, we may even want to change the number of rows because now we have 10 values. we can say the number of rows are 5. Let's add here maybe 10. That's 10. So that we have number of rows equaling to 5, right? So number of row equaling to 5 by row equaling to t, which is true. Now we want to add the names. For us to add the names, we have to have this thing called dim names. Let's go back to our question, to this thing. So matrix data is equaling to that, whatever it is that you've declared here. Now end row, now we have 5. Number of columns, we don't have to pass that. We can just use an end row by row equaling to true. Then dim names. Here is where now we are. Dim name means the dimension names, right? The names of the dimensions that we have. So dim names is equaling to list, right? You have to ensure that you've written this argument. List now in bracket row names and call names. We are writing row names here because we had already declared them, right? Row names, call names, and then you can run it. There's an error. Where are we getting the error? Not equal to array extent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. It's because our number of rows are 3. Like the number of rows are 5. So the columns are 2. So let's change this, and we have 2 columns. And then here we have another thing, row 4 and row 5. Row 5. Control enter, and now try to run this one again. And then run our mat. So you can see here we have row 1 is 11.0 and 22.0, row 2 30.047, row 3 45.016, row 4 71.0. So you can see row 1, row 2, row 3, instead of having them this way, like 1 was mentioning that it's row 1, 2, 3, right? And then you can even see our column names are now call 1, call 2. I mean, these are things that you can even be having, maybe these were cases or maybe respondents fill in their data. So you are doing a research. Response number 1 from maybe John Kiriamiti, umeandika hapo column number row number 1 ni ya answers from John Kiriamiti. Row number 2 maybe Ken Walibora, and row number 3 Said. Row number 4 you have Francis Mbuga hapo. Row number 5 you have Bertolt Brecht is there, right? And then call number 1 maybe age. Call number 2 is country. Column number 3 is maybe net worth. Column number 4 number of books written. Column number 5, you know what I mean? Yeah. So that is how you can declare dim names so you use the list. This thing, I suppose that somebody has been confused and needs time to understand what we've written here. Who is confused? Victor, are you okay? Uh-huh. Kasola? Okay. Nathan?
Yeah, I'm okay.
Okay. Alvin? Okay. And I believe also the rest are Uma. Uma is. So again, we can even get dimensions. So for example, what is the dimension of our mat1? Dimension of mat1, it is a 5 by 2 matrix, right? What is the length of our mat1? It is 10. So we had 10 entries, right? Are we together? Okay. We can combine two matrices. But again, go and learn more on naming of these things. Or this one, particularly this. Kindly go and look at it with the third eye. So we can also use we can combine two matrices, and this one you can do using something called R bind and C bind. There's R bind and C bind, which you can use to combine two matrices. Okay. There's something called R bind and C bind. If you don't know more about it, you can you try to type help and see. So you can see R bind. Take a sequence of vector, matrix, or data frame arguments and combine by columns or row, respectively. These are generic functions with methods for other R classes. You can just type and control enter, and you see it has popped up here. You can go even up to examples. So you can combine using C bind, or you can combine using R bind. So you can create two vectors, two matrices. Yeah. So you can even have two matrices. So for example, our mat1, let's just copy up to here. So maybe I have number of rows equaling 2, 3, right? I have mat1, and then I have also there was this one for mat. So I have mat1 and mat there. Can you try to combine them, mat1 and mat? So you'll have maybe uh, mat2. Unless I'm missing that, it should be mat, comma, mat1. Let me see if it's yeah. So mat1, mat, so mat2. Yeah, so mat2 you can see mat2 now has combined. We have combined them row wise, right? R bind means you are combining them row by row. So you see that values for the first vector is here, which was 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we add another row of the second column of the second matrix that we had. We can even decide to do it in using C bind. C bind is now like a column bind. So let's mention this as mat3 and say C bind and do mat3 there. Control Enter. You can see now you have combined them column wise. So we have the values of the first matrix here ending up to 9, 6, and 3, and then we have the values of the second columns of the second matrix. So we have added more columns, right? I think that is something that is simple for us to understand, right? Now you can access what is you can access matrices the same way we did in with vectors, right? So suppose maybe you want to access information in the first row, third column. How are you going to do this? Information in the, what is the element in the first row, third column? Somebody to tell us that, how to do it. Somebody to fly away. We are about to end. Somebody to show us how to do that. Okay, so we want to access maybe information in mat1. Mat1 has how many columns? So mat1 has 3 rows. So let me type mat1, and I want to access element in row number 1, column number 3. Sorry. Yeah, so it was not running because of what we had here. What are they? So we want to access information in mat1. So it is mat1 row 1, column number 3. So where is our mat1? So if you run mat1 here, control enter, and press mat1, you'll see that row 1, column number 3, we have 30, right? That's understood, yeah? So mat1, what are the elements of the third row? If we only want to see elements of the third row, so this one needs not to maybe mat1, we want to see elements of the third row. Row number 3, you just type 3 and put a comma there. And then you'll see row number 3 contains 71, 8.1, and 9.9. What are the elements of the second column? We'll just type again mat1, and then you have and then put a comma and 2. You see how it is written? This is what you want, we are busy with, right? Or maybe interested in. So you can see 22.0, 25.0, 5.1, right? And that's that. You can also access more than one row or column. So somebody can tell us how to do that. You can also access more than one row or column. How can you access more than one row or column? I'll leave that for you to go and do now. Go and do this. We are saying that you can also access more than one row or column. And again, similar to what we did with the vectors, you can add and subtract, multiply, divide two matrices, right? You remember what we did with the vectors here, where we were saying that you can multiply and things like this here. Okay. Yeah, all these things that we wrote there. So you can also add, subtract and multiply two matrices. So you can even just have this as even x. So addition, maybe mat1 and mat, because we have two matrices called mat1 and mat, and print x, right? So it has added the matrices that we had, uh, and so it has added 1 plus 11, 12, 2.0 plus 32.0, 24. Yeah, you can see it there. And yeah, that is how you'll do it. For something like maybe multiplication or maybe division. So maybe multiplication. Oh, we are talking about division here. And this is your answer there, right? And then maybe multiplication, you have them there, and multiplication happens that way. Yeah, and similarly, you can do subtraction and call it x. Of course, these things you can call them different so that you don't have the same name for. But because of time, I'm just hopping around with them. So R is overwriting everything that it had thought about or we had given it. So 11 minus 1, 20. 22 minus 2, 20.0, right? And 30 minus 3, 27, right? And so that is how you will do all those things that we did. Next, we are supposed to look at list, and after list, we are also going to look at data frames. These are things that you did also in even in and on top of that, you can also look at arrays. So we'll see. These ones are going to be cheap, of course, because of what you have done today. They are going to be most likely. Yeah. Any question? Are we okay?